far in this unit, we've taken a look at composite functions and inverse relations. Today we're going to combine the both of those. Now, when we combine the both of those, we're going to come up with this inverse function theorem. Now, it simply states that f to the negative 1 is the inverse function. When the function f of x has an inverse, then the composite function of f and its inverse in either order is the identity function, which is the function y equals x. So in other words, f of f inverse should be equal to f inverse of f, and they should both be equal to x. Now, this boils down to this inverse function theorem. Two functions f and g are inverses if and only if f of g of x is equal to x and g of f of x is equal to x. So that sounds really confusing, but if we go ahead and put that into practice by doing a few examples, we think you'll catch on really quick. So let's take a look at example 1. Function f of x is 4x plus 5. G of x is 1/4 times the quantity x minus 5. Determine if these guys are inverses by composition. So let's start off by evaluating f of g of x. Remember, that means we're going to take g of x and substitute it into f every time we see an x. So that becomes 4 times 1/4 x minus 5 plus 5. Now, when we simplify this, we're going to multiply that 4 inside of the 1/4. So that's actually going to go to 1 times the quantity x minus 5 plus 5. Well, 1 times anything is just itself. So that's x minus 5 plus 5, which simplifies to just x. So we say f of g of x is in fact equal to x. Now let's flip-flop that and let's find the composition g of f of x. So now we're going to go back the other way here, and we're going to take our f of x and substitute it into our g of x every time we see x. So we have 1/4 times 4x plus 5 minus 5 inside the parentheses. Now we're going to simplify what's inside the parentheses first. The positive 5, negative 5 goes away. We have 1/4 times 4x, which results in x. So we say g of f of x is also equal to x. Now, keep in mind our inverse function theorem says if f of g of x equals x and g of f of x equals x, then we say yes, these guys are inverse functions. All right. The last little part that says, what do you notice about the composite of the function and its inverse in either order? They are commutative. So you can multiply these guys in either order, and you will find out that either way they're going to end up equaling x when they're inverse functions. Okay, it's important to do multiple examples of this. This is kind of a confusing little topic, so let's try example 2. We have a function f of x is 5x minus 3, and we have g of x, which is 1/5 times 3 minus x. Determine if f of x and g of x are composites. So let's start off by taking g of x and substituting it in here to f. So we have 5 times 1/5 3 minus x minus 3. Oops, now let's close up that parentheses there. All right, we'll take that 5, distribute that in. That's going to go to 1, so we're left with 3 minus x minus 3. And when we combine like terms here, we're going to be left with negative x. So we see that f of g of x is equal to negative x. All right, now let's try our composite function for g of f of x. Switching directions now, we're going to take our f of x and substitute it in here for x. So we have 1/5 3 minus 5x minus 3. All right, let's start by simplifying inside the parentheses. We've got to distribute this negative in. So we have 1/5 times 3 plus 5x plus 3, which becomes 1/5 6 plus 5x, or 6/5 plus x. So you can see that this is our result, of g of f of x. You can see that f of g of x is not equal to x, and g of f of x is also not equal to x. Therefore, we say that no, these are not inverse functions. All right, let's take a look at example 3 here. Now we want to find an equation for the inverse function if the normal function we have, or the original function we have, is f of x equals 2x squared minus 7. We want to then show by composition that these functions are inverses. Alright, so remember our two steps. We're going to first switch the x and the y. Alright, so we have x is equal to 2y squared minus 7. And then the second step is to then solve for y again. Alright, so we're going to start by adding 7 over, and now that's equal to 2y squared. Divide both sides by 2, and then take the square root. So that will give me y again. So my inverse function here for f of x is the square root of x plus 7, all divided by 2. Now we're going to show by composition that these functions are inverses of each other. So let's calculate f of f inverse of x. So we'll take our f inverse here and we're going to substitute it into our function f of x. So that's 2 times, in parentheses, we're going to put our square root of x plus 7 all over 2 squared, and then subtract 7. Alright, well, the square and the square root undo each other, so we're going to be left with just 2 times the quantity x plus 7 all divided by 2 minus 7. Now the 2's will cancel each other out, and I'll be left with x plus 7 minus 7, which results in x. So we say f of f inverse of x is in fact equal to x. Now we got to flip-flop that and go the other direction. So we're going to take the inverse of f of x. Okay, so we're taking our 2x squared minus 7, and we'll substitute it under our radical here. So we get the square root of 2x squared minus 7 plus 7, all divided by 2. So starting by simplifying inside the radical, our minus 7 and plus 7 will cancel out. I'll be left with the square root of 2x squared divided by 2. Well, the 2's will cancel out as well, so I'll be left with the square root of x squared, which is in fact x. So we now know that f inverse of f of x is also equal to x, and therefore we've shown by composition that these are inverse functions of each other. All right, one more example here. We have the function h of x, and h of x is given by 4x plus 7 minus 3, all divided by 2. We want to find the equation for its inverse. So again, step 1, we're going to switch our x and y. So it will now read as x is equal to 4y plus 7 minus 3, all divided by 2. And then our second step is to solve for y again. Alright, so we're going to start by getting y by itself by multiplying both sides by 2. So that gives us 2x is equal to 4y plus 7 minus 3. And now we'll add our 3 over. So we have 2x plus 3 equals 4y plus 7. And finally, next we're going to subtract 7 from both sides. So we have 2x. And we can combine these at this time. So this is going to be minus 4 is equal to 4y. And then our last step is to divide both sides by 4. So our inverse function, h to the negative 1 of x, is given by the equation 2x minus 4, all divided by 4. Now if you want, you can go ahead and simplify that. That can be simplified to 1/2 x minus 1. So there is our inverse function for h of x. Alright, example 5 asks you now to find by composition g of h of x and h of g of x. Go ahead and pause the video now and try this one on your own, then press play and see if you got the same thing I got.